Thank you for taking the time to watch my talk. Really looking forward to presenting to you. I would be much happier to be actually on site, in presence. I think we're all looking forward to actually meet people again in real life. But we'll have to do with this, and I think the organizers here are doing an amazing job with this so far. So I'll try to do my best to do this in a virtual, interesting way as well. So my topic today is good enough architecture. I gave this talk before and afterwards. Somebody approached me and said, "Okay, this was the session's title, but maybe you should have named it something different." So I decided to have that as an alternative title as well. So this is actually the statement somebody expressed after the talk. So prepare to be a little frustrated by some of the things I tell you. If you feel like I'm talking about your project, of course you're wrong. This is nothing of those things that I mentioned here could ever happen in any of your projects. This is just a similarity. And of course, to protect the innocent, I have, well, sometimes the not so innocent, I have anonymized a lot of things. But in general, you might run into projects that have some of the problems that I'll talk about. And I hope we can all learn something from that together. Before I dive into some example cases, which is going to be the majority of the talk, I want to say some generic, or what I think are generic truths about software architecture, because I sometimes have the feeling that architecture these days has a bad name. Some people think architecture is something that people used to do in the past, not something that people should be doing in modern software development. So there are some fundamental things that I want to get across first. And the first of that is architecture is not that activity where somebody creates a lot of paper or a lot of fancy diagrams and puts them up on some wall and nobody ever looks at them. And it's also not people creating tons of paper to put in a giant binder and hand over to somebody to then do as I tell you, and then just implement what I gave you as an architecture. That is not the case. Architecture is not an upfront activity that would be formed. In fact, I believe that architecture is not even documentation or any abstract thing. Architecture is something that the system you're looking at, the system you're building, exposes. It's the sum of its most important properties. It is something that your software will have, and the only question is whether you let it happen to you or whether you take an active role in designing the architecture. That is the first fundamental point I want to get across. Whether you consider yourself an architect, or whether you even have architects within your teams, or whether that is a role that you identify, or whether that is just something that people do, whether people do some architectural work as part of their job, that's all fine with me. I'm not a fan of titles, and I don't think that is the most important point. So that is statement number one I want to get across. The second important thing I want to get across up front is that if you look at this task here, you'll find that it's pretty hard to make a rational decision here without knowing more about the context. And in a similar way, picking the right architecture, picking a good architecture, assessing whether an architecture is good or bad is mostly about checking whether it matches the context, whether it matches the requirements that you're in. Those might be functional requirements, semantic requirements, or it might be, and often is, a lot of quality requirements. If you walk across this very formal thing, you'll see a lot of things that might be important quality aspects of your system. But in no case can you just simply copy those requirements from one project to the other, because every project is different, every system is different, every product is different. You'll have to figure out how to weigh those different things against one another and how to decide what's most important here. Because, for example, a system where the number one requirement is that it's super secure might be built differently than a system where the number one requirement is that it's usable. And of course, other things are in this continuous tension as well. You always have to figure out what architecture matches your specific context. In fact, when you look at some of the cases I'm going to present, you'll find out that a few times architectural principles or architectural design ideas have been taken from one context where they match to another one where they don't. And that very often creates really horrible problems. Also, there are words that are used much too easy, like scaling, right? Your system needs to be scaling. What does that even mean, right? What does scaling even mean? Let's take just two possible axes here. One is the logical complexity. Does your architecture scale to a more logically complex system? And the other dimension is the load. How much load will that system have to handle? And if we now elaborate on those axes, then we might have something that just needs to serve a dozen users, up to something that needs to serve half the planet. Or we might have logic that could be written on a rainy Sunday afternoon versus something that depends on German tax law, my favorite example. If we position a number of prominent examples here, example systems, then that random CMS that just manages some stuff is probably pretty low on both scales. Whereas something like Twitter is very interesting in terms of load, but the complexity is actually not that super impressive. I'm sorry if I offend any Twitter attendees here, but there are definitely more complex things. For example, I think that Netflix is a more complex thing. It also handles more load. But there are other systems of a very different kind. Like we have those things like Facebook and Amazon. And Amazon, I would say, is something that has a lot more logical complexity with the platform and everything. But we also have things like a policy insurance policy management system, which is probably, in some ways pretty boring. It also doesn't typically have the huge load that the others have to handle, but it is super complex in terms of the actual logic. No solution, no architectural solution can match all of those cases. You'll always have to adjust what solution you pick, what choices you make, and adapt them to the context you're in. It seems kind of obvious, but there is no good or bad architecture without talking about that context. Okay, so that was statement number 2 I wanted to get across. So let's dive into those cases that I wanted to present. I think I have 9 or 10, and I'd like to hit most of them. If we run out of time, we'll skip a few, but let's just give it a try. I'll always present you with a little bit of context, anonymized, of course, but so that you get a rough impression of what the project or the product is about, some observations, and of course, some lessons learned. And I've always labeled them with a headline that sort of highlights or attempts to highlight the main problem here. The first one is this non-extensible extensibility, which is a very common thing. And this particular example I have here is still on my mind. And I keep using it as a good example for something bad happening here. So the context was a global, huge e-commerce retail provider. So they essentially sold digital goods, or they still sell digital goods globally. And they're essentially focusing on the usual stuff that you have in such an e-commerce context, right? You have a catalog, you have a lot of product description data, you have the actual shop where you can buy something, and you have fulfillment, which in this part mostly means being able to download and activate and license software or other digital goods. The interesting thing here is that is a multi-tenant system. That is, they don't sell their own products. They offer a platform where you, if you have something to offer, can easily set up, or hopefully easily set up your shop. And then they will take care of a lot of the intricate details of doing that globally. They're highly customizable, and that is the thing I'm going to elaborate a bit on. Highly customizable here means that they aim to be able to fulfill every need you might have with your particular e-commerce needs, right? So if you want to sell something to your end users, they want to help you to do that in exactly the way you want to be able to do that. So you can, again, draw a little diagram like this and say we have different clients with different needs, right? We have different budgets with different clients, right? We have this one axis that has the acceptable cost. How much is a client willing to pay? And we have the axis of customization needs, right? How specific is it what they want to do? How different from what the general public wants? And of course, they have very large customers. In fact, they have a few very large customers that are so strategic that they make up about, I don't know, a third of the revenue of the whole company. They have a ton of very small customers, sort of the long tail customers, right? You typically have this curve, right, where very few of your customers make up a lot of your revenue, maybe 80%, and then the rest is spread over thousands and thousands of smaller customers. Now, if you look at the needs of those two groups, they're very, very different, right? The budget that a long tail customer, long tail is the term for a small customer that makes a small amount of business, but you have a lot of them. If you have a lot of those small customers, they won't be able to pay you a lot, but they also won't have super specific needs, right? They're pretty generic in what they want to do. Whereas the large customers have very specific ideas about how they want to sell their stuff. They will not be willing to compromise on many of those, but they also have a huge budget. They can throw a lot of money at you. Now, the problem was that this particular provider here developed a solution that was very fancy, allowed for a lot of customization, was actually built using its own IDE. So you had to download an Eclipse-based IDE with a few gigabytes of download to have this development environment that allowed you to customize your shop for this particular platform. The problem with that was that solution sat squarely here, right in the middle where nobody liked it. For the people who were in the long tail, it was way too complicated. They didn't have software developers. They just wanted to fiddle with colors and maybe change a picture or a logo. Whereas the large scale customers had specific needs that were way more complicated than anything that could be done with this particular solution. So in the end, the only people using it were the ones working at the company itself. And it was hard for them to find any people who wanted to do that because they all hated to work with this particular proprietary IDE. Good developers want to work with standard tools, with well-known tools. They think of, is this something where I should learn? Will this, if I learn this thing, will it help me in my next job? So in the end, what happened was that they designed something that attempted to satisfy everyone and ended up satisfying no one. That is a very common case. Happens a ton of times. Every time you go with those two generic, too configurable solutions. And sometimes, no, I'll say very often, specific code, highly specific code is preferable. You can spend days and weeks and months about fiddling with configuration machinery, but very often it's much better to just simply develop what's needed here. So in this particular case, the solution that we arrived at, that we recommended and that they implemented, was to develop specific systems for those large-scale customers and scale back a lot on the configurability of the main system to make it much more simple, much simpler for people to use. So that was my number one case. Let's move on to number two, because we have a number more coming. So this one I've labeled perilously fine granularity, and it is, I just learned from Kevin and Henny that we have the 10-year anniversary of microservices, so it won't be a surprise that it has something to do with that. So the context here was a large-scale B2B food retailer. So think of somebody who delivers food to restaurants and other B2B, other businesses who then do some end-user business with that. And they implemented a new company-wide shop and logistics system. So a really huge thing. I think it was actually more than 300 developers, a huge effort, a program actually, not a project. And of course, they wanted to do everything in the state-of-the-art way. And the state-of-the-art way these days looks like this, which means a ton of microservices, right? So everything was cut up into these little pieces. And obviously, that's a good idea, because how could anything be wrong about microservices, right? I think actually these days it's become quite fashionable to think everything's wrong with microservices. Of course, the truth is somewhere in the middle. But in this particular case, the program ended up having several teams working on this thing. And those teams always had a context of a number of microservices that they needed to work with. So if team one had this particular cluster here and team two had that one, you can see that there's a little overlap here, right? There's this little service that both of them needed to use. And if you add more teams, you get more overlap, right? You get a fight about who can change this particular service, because changing it means that all the others using it have to test their stuff. And changing it means that you have to synchronize your change. Changing it means that you have to maybe have a meeting with the other people needing that particular thing. And if you look at that little service in the middle, I've actually found out that this next slide is actually a very generic one. Even though it was inspired by this particular project, I keep being able to use it in a number of projects because it's always the order service. In any e-commerce scenario, the naive implementation always has these entity-based things, right? An order seems to be such a central thing. We need to have a service doing that. And then you have a ton of other contexts using that particular service. And if you're into domain-driven design, you'll notice that the problem here, right? The problem is that an order from viewed from different contexts is actually not the same thing. So this order ends up as the superset of all the needs, of all the requirements that everybody has to this particular abstraction. Everybody needs to get their attributes in there. Everybody needs to get their functionality in there. So this order service tends up to be this very generic thing, or very reusable, I hate that word, thing used by numerous contexts. Now, that is a problem because every time one of those teams, the billing team or the support, or the checkout team wants to do something, they have to synchronize with all the others. That seems such an obviously bad idea. Why would anybody do that, right? Does this give you any hint? Why would does the choice of font and colors that I've picked here give you any hint why people would want to cut things up into those hard to manage fragments? In fact, with admiration, I blame this particular company, right? Because everybody wants to be Netflix, but nobody really is. And Netflix popularized this particular scenario. Now, it might make sense for them. Even that could be questionable, but let's just assume Netflix knows what they're doing, right? They're super smart people. They pay a ton of money. They have the possibly smartest people in the world who are willing to move to Silicon Valley, whatever. So they have a ton of very smart people. And they maybe have found an architecture that works for them. But why does everybody else keep thinking it would work for them? Who here is building a video streaming platform for 1 billion users? I doubt that it's many of you or us who are doing that. So in fact, I think copying that architecture from one context to another is a source of problems, right? In this particular case, the architecture should not be optimized for scalability in terms of the hundreds of millions of users it needs to serve. The main goal here was to scale it in terms of parallel development with multiple teams, right? So the solution was more to move those things back where they belong, and in the end, go do away with this particular service, right? The context got a little larger. The services got a little, in fact, there was quite a bit of redundancy introduced here, which was all perfectly fine because now those teams could move way more independently. So the lessons learned are small is not always beautiful, right? Cutting things up into these super small pieces might actually hurt you if you cut them up wrongly. And one of the key insights here is that the team boundaries matter a lot, right? Refactoring within team boundaries is much easier than globally across team boundaries. You know, any sort of work is nicer if you can do it within your team with the people you work with very closely, as opposed to having meetings with people from other teams. And you ignore organizational parameters at your own risk. That is, in fact, Conway's law, which I won't drone on about in this particular talk. But this relationship between organization and architecture is probably something that most of you are aware by now. So let's move on to the next one. And again, feel free to drop questions in the Slack in the meantime, or comments or agreements or disagreements if you want. So the next thing is that the system you're building will be dynamic, even if you don't intend it to be. So this particular context here is a large-scale insurance system. And it actually has existed for quite a while. It uses model-driven development. That's one of the ways you can tell that it's been around for a while. It has a little more than 100 developers, and those 100 developers are just there for maintenance, right? This is just to add new products, to add new services. It's in continuous maintenance. It has been in production for a while, and these 100 people keep adding new stuff twice a year. So don't think this has anything to do with continuous deployment or anything absurd like that. This is really traditional, old-fashioned 2 releases per year, and actually proud of 2. So one of the reasons, or the major reason why this happens, is because the development process is so optimized, which sounds kind of weird, but it's an effect of their implementation strategy. So what they do is they have this flow. I wouldn't call it a water flow, even though it is. They have this flow where right in the middle, they have this modeling phase, right? This modeling phase essentially means that you make all the important changes, specifically changes to your object model, right? To the entities and their relationships and the attributes and all that stuff. And you maintain that in a huge model. And from that model, code is being generated. Now, the problem here is that the code generation facilities and the tooling used here is pretty old. And it is a bottleneck that only one person can use at a time. And that is actually one person. There is this one person. She does this every year. And she has this slot of about 2 weeks where she can actually do the modeling, because the rest is all dependent on that, and all the complex testing and all the stuff that they have to do mean that they only can do one modeling session of one modeling slot of 2 weeks in half a year. So what happens if you miss your slot? Let's just assume you're a product manager. You want to do something fancy, but you've just missed it. I mean, your competitor is on the market with that thing. You want to add that too. Now, you could say, well, I can't do that now, but one of the problems here is that people will find solutions. People will find a way, right? So the way they found here was they have this object model, and then when they have a need for a change they can't do, they look at it very closely and decide, well, what isn't that important? And then they decide to change something. So an attribute in a model might actually mean something completely different. And they maintain a huge Excel sheet, and I wish I was joking. They maintain a huge Excel sheet that has a mapping from what the attribute actually says in the code versus to what it actually means, which is, I think, completely ridiculous, but in production for a long time, running a lot of money or maintaining a lot of money, generating a lot of money. And this is really a horrible thing, because the poor person who does the modeling spends the first week of her 2-week slot, at changing these things to something actually meaningful. And then you have to change the code, of course, to work with the real stuff, because otherwise they would go completely crazy about the whole thing. So lessons learned: centralized responsibility, even not only at runtime, but also within your development process, creates bottlenecks. Those bottlenecks hurt everything and everyone, and they create a ton of problems. So if you can move for autonomy, that's a much better choice than moving for efficiency, because of this simple reason here. At least if the project is more than a trivial size. And the second thing is that if there is too much rigidity, if you don't allow for flexibility, people will find a way. I've seen this in numerous places where people weren't allowed to introduce methods. So an existing method was used and had just a ton of more parameters, specifically in code generation or distributed development scenarios, right? It's incredible. And one of the things here was that everybody who came into this project, and they had quite a bit of churn, found this ridiculous and screamed about it for a few weeks and then just got used to it, right? So just because you're used to it doesn't mean it's acceptable, right? Sometimes you have to question those things and figure out what you could do instead what you can do instead to accommodate those needs. In this particular case, it would have been to maybe add some dynamic attributes or go do away or modularize the things so that you could have parallel modeling, stuff like that, right? So one of the questions in the chat is, does the perfect architecture exist? Does this, is there such a thing? Is there a perfect architecture for a specific context? I think not. I don't think we can ever claim that we found the perfect way. I think we can say that we found something that matches our understanding of the requirements, but somebody else would have definitely come up with a different architecture, and that might match them just as well. So I think there are many good architectures for a particular context, and claiming that one of them is perfect is a bit of a stretch, I think. Maybe this is actually a very good question. So one of the reasons I ended up doing this in a slightly negative way is that it's much easier to point out the mistakes, much easier to point out where something went wrong than to claim this is the perfect solution. I have some positive examples though as well, and we'll get to them in a while. So let me move to the next thing, the horizontal Conway split. So I mentioned Conway's law, which is this relationship between architecture and organization. And this particular effect of it is one I've seen recently way more often than I'd like. The context that I've picked here is a project where we're tasked to build this unified communication platform. And it was pretty much straightforward business logic, but there was a high scaling requirement in terms of load, in terms of the number of users the system was supposed to be able to handle. So it didn't have these huge complexities in terms of the teams, but it had like 10 or 20 developers. So it was a significantly enough size of the whole thing. Now, the problem with this particular setup, and again, something that I observe quite often at the moment, is that there were two groups of people that were different in terms of their language choice, right? So you had the group of people that thought Java is a thing old people use, whereas you had the other group that thought JavaScript is not something that can be used in serious programming. And both were very strong in their opinion, right? So what happens if you have these two groups? If you have these people who naturally group into those two clusters? Well, if you follow Conway's law and say there's a relationship between organization and architecture, it seems like, well, this group looks like it might make up pretty good team boundaries, right? So we'll just move them to those two things here, and we'll have group one who hates Java build an HTML, CSS, JavaScript front end, whereas the other group can build a Java backend. And then we'll connect the two with a JSON API. Now, I have a lot of problems with this particular thing. One is that I don't think this is a particularly good architecture, and I could dive into that for an hour, but I can't because I don't have the time. But the more important point here is that even if you think this is a good architecture, the reason it was chosen here is not that. The reason it was chosen is not that somebody thought this is the right architecture for this problem. The reason it was chosen was that the teams didn't want to cooperate, right? That the people, the humans, didn't want to learn something new. The Java people didn't want to learn the HTML, CSS, JavaScript stuff. The JavaScript people or the front-end people didn't want to fiddle around with Java or with the back-end stuff, although that's a little questionable, right? Because there are tons of problems with this. What's the problem here? The problem is that you have to collaborate. You have to talk to each other now, and you have this JSON API, this API that you now have to design in detail, that you have to evolve, that creates this friction between those two things, right? And then typically what happened, didn't happen in this particular project, but very often happens in project like this, is that the back end moves too slow for the front end. And then what happens is that the front end people will quickly become full stack teams. They will develop stuff in there. The same thing could be said for Android or iOS development, right? They develop things on their own because the backend team can't move at the speed that they want to do things. The problem is that every meaningful feature development requires front-end and back-end work. If it's just the front-end or just the back-end, it's not interesting. If it's supposed to create value, it'll always be both. But people will accept anything, right? They love to stay among their own. They like to not learn, not leave their community. They love to learn new things, but those new things have to be in their own community. I know I'm criticizing a lot of you here, criticizing myself because I have this experience with my own history of software development, right? You always like to stay and figure ways out of it. This is sort of an appeal to be a little more open about this and think more in a full stack way. So now that I've ranted about this particular thing, I thought it might be a good idea to give you an alternative here, right? So I've highlighted this particular thing, which is actually, I think, a good example of something that happened in a project. The system of systems approach taken here was an e-commerce online shop scenario, pretty big team, 100 to 120 developers for a very, very big retailer, in a very big European retailer based in Germany. They had like 10 self-contained teams. That was their goal. They wanted to move in parallel. They wanted to develop very quickly. So they had this idea here. And there's a little slide that I keep showing in a number of talks, which is this one, right? If you look at the right methods of decoupling or how to reduce coupling, this is related to the size and to the complexity of the problem that you have here. If I'm developing something on my own, I don't need much in terms of decoupling. It's just me, right? I know my own, well, I know most of my own head, probably can understand 1,000 lines of code that I wrote. So I'm fine with a few methods. And if the number of people collaborating increases because the architectural or the semantic complexity increases, you might need something else, like maybe modules, or you might move to components with a component runtime. Or you might even move to microservices because you want that extra boundary with the network boundary in there. Now, my claim here, the most important point here is that I believe there's something beyond a microservice, which is actually a system. And I think we need to think of system boundaries as something important as well. So that's what this particular project did. Instead of thinking of a layered system, right, where you have these layers, like we all know, and then you have modules within them, they sort of promoted the modules to a top-level construct and made them systems. So the very first thing they did was think of how many systems are we actually building. And that created a lot of freedom for them to use that particular layering in one system, but a slightly different one, or maybe different choices at different layers in the second one, or a more database-centric approach in the last one. So what they did was they gave the individual teams more freedom, and they had this. They moved away from this scenario where you have one big architecture and then a lot of decisions made for everyone in the same way, just because you wanted to have everything done the same way, because you think that heterogeneity is a bad thing. They actually accepted that as a good thing. They also went away from this front-end monolith that you can see in many typical microservices architectures, where you have back-end microservices and lots of them, with a huge monolithic front-end application, to something that was more like those, vertical things. Like those systems were connected mostly in the front end, and they actually used a lot of web technology to actually connect them. This is an architecture that we've now been using in a number of projects. We call it self-contained systems, and you can find a ton of links and talks. Not going to go too much there. what I want to point out is that these things are an important aspect of your architecture, right? The choice of which systems to build is probably the most important architecture choice that you make. Even if you just decide to build 2 systems instead of 1. Because most of the time, the people who have set up the project, who have allocated the budget, they don't care about architecture. Very often the context is already set for you and you have to figure out what to do with it. And sometimes it's much better to build more than 1 system. Whether it's 2 or 7 or 15 really depends on the context again, but it is a choice that you should be making consciously as opposed to letting it happen to you. Once you do that, there's just one thing to keep in mind. If you want to do this extremely loosely coupled thing, you need some rules and you need to enforce them quite strictly. So it's like a quid pro quo, right? You give people a choice in the micro area, that you give them a choice to do a lot of things internally in an approach that they can decide locally, going for a local optimum. But you have to have some rules as to make the whole thing work together, like integration rules or front-end integration aspects, or maybe a common design system for user interfaces, stuff like that. So there was a question, I think, what are we supposed to do as an industry if not everyone wants to be a full stack developer? Because I think that's an excellent question. It highlights both those 2 things, right? The Conway split as well as the system of systems thing. Because in both things, I've argued that you should not be making this split horizontally, you should be making it vertically, right? So in fact, if you look at my first picture regarding the Conway thing, then I argued that, you know, this thing here is not a good, sorry, the animation kills my story here. So this particular thing is very often not a good choice, right? That is my first statement. If you scale that up in a team size fashion, it means that you should not be having a front-end team and a back-end team. You should rather be having vertical teams, right? This is the team that does fulfillment, and that is the team that does the catalog, or whatever your context is. So it's sort of the same thing. And the question is extremely valid. Does that mean everybody has to become a full-stack developer? No. In fact, I think real full-stack developers are super, super rare. And even if they exist, they can never have the complete depth in all areas. That's simply not possible. There are too many things going from user experience, visual design, HTML and CSS, over JavaScript development, over all of the website architecture side of things, over the logical aspects, up down to data things. And it's just an illusion that somebody can do all of that equally well. But a team should be a full stack team. And that's a different thing, right? You should be working very closely with people, and you should be building a feature together. Maybe it's a pair who does that. Maybe you can do most of that and they get some help with that aspect, whereas somebody else needs your help with their work. So a full stack team as opposed to a full stack developer. Right? So can I share a good resource talk for a system systems? I'll do that later in the Slack, right? So I can provide some extra links later on. And there's also an interesting question. What is your experience with the usage of a canonical data model in a large-scale multi-team development? In fact, that would be an excellent entry as an anti-pattern here. I wrote a blog post about it, which I'll share, because in general, I think that the canonical data models are just, in general, a very, very, very bad idea, because they create a ton of coupling that you can avoid and that you should avoid. Oh, I'm not making any friends in this particular talk, but that's okay. So let me move on and try to get 1 or 2 more examples in here. So this one is one of my favorite, because it's I think a relatable story, right? I called it Freestyle Architecture, and it's about a company that we work with that no, let me move to the next one. I wanted this one, actually. This one. I wanted Cancerous Growth, not the other one. I'll skip the other one. So this was a company we worked with that acts as an independent as a financial service provider for independent brokers. So those brokers sell financial products, and they can use the services of this particular company. So it's a pretty innovative, or was a pretty innovative business model when they started, and it still is a market leader in its particular segment of financial products, and does an excellent job of providing a platform for people to serve their clients. Now, as many other companies of this kind, it started out pretty small with a focus on product development, and then grew into a larger group that has like 30 developers. So it's not a multinational conglomerate of any kind. It's a nice valuable, profitable company, 30 developers, maybe 100 to 200 people work there in all. And they have this 20 years of company history where they grew, and as they grew, their software grew with them, right? So when they started, and you can tell a lot about when they did that by this particular architectural technology choice here, it was all focused on getting things done in the fastest possible way. And somebody thought back then that this was the solution. It was actually probably not a bad solution then. But as they grew, they kept adding stuff. For example, somebody decided to do things a little more professionally and not with this 4GL tooling, and decided to do a lot of Java, and back then JSPs, Java server pages in the web app, and also added a ton of PL SQL, so programming language within the database. So this was the solution for quite some time, until somebody came along who didn't like Java and added quite a bit of .NET web services. So they had this coexistence of .NET and Java-based services. And then they decided to buy a company. And they decided not to use their systems, but instead move them onto theirs, onto their own, onto the existing ones, to this one. But they found out that it was pretty hard because they were slightly different. And then they decided to not change their systems to adapt those needs, but rather just duplicate them. So now they had this thing twice, right? With slight differences in the business logic, until a few years later, they figured out that this was getting too expensive. So they consolidated the database. That was good for a while, until they found out that there are other interesting things. So they got a new CTO, or new technical decision maker, who decided that other data technologies are interesting as well. So now they had this huge collection of different things. And of course, that was not enough. So they kept adding and adding and adding. And one of the favorite things I have here is this little thing here, a C++ encryption library. They were pretty security conscious and wanted to have a good solution for encryption. So they picked an algorithm and then they implemented that. That is not the best possible solution. That rather pick an implementation that's proven and checked by somebody in open source thing, almost exclusively the better choice than to do something like that yourself. And this actually proves it, because when they did that, they introduced some errors, which is, I can forgive that. They have had some bugs in their implementation, but the problem is that they used this buggy implementation to encrypt a lot of data, which now sits encrypted in their storage. Now, the problem is that the only decryption they have available is in this particular buggy implementation. So they can't switch to a different implementation, which means that they have to keep this C++ implementation running, which was written, I think, using Borland C++ and runs in a virtual Windows VM on some system right now until this day. I think this is such a mess. It's a fantastic example. I don't want to blame anybody here, because nobody chose that, right? Nobody chose to make things this complex. And that is, I think, a very common thing, right? Sometimes successful systems end up with the worst architecture, because what happens is that it's always features that have priority. It's always, and there's a business running there, and there's a new need, there's a new opportunity. You can add this particular feature, and you can make more money, you can create extra value, which is fantastic, right? And you end up with those things. Nobody ever has time to spend on optimizing architectural things, right? You're always focusing on creating business value, and you can do that for a long time, even with a messy architecture. Right? The thing I want to point out here is that unmanaged evolution will lead to complete chaos, right? Evolution is fine, and it's a fact of life, and it's actually something that you should embrace. But you have to be aware that if you don't make the choices, they will be made for you. They will just be made by accident. They will just happen, and you don't want an architecture happening to you. That is not a good thing, right? Don't be afraid of some light. Architectural governance. I chose those words deliberately, right? That's a for many people, that is a horrible statement. Architectural governance sounds like the most enterprisey BS that you could do. But in fact, it just means that you have some boundaries, that you make some conscious choices as opposed to letting things happen to you. Okay, so let me conclude with the last one, and then maybe address some more of your questions. So this one is improving with less intelligence. I found that one of the problems with complex architectures, or with architectures gone bad, is that people are too smart. People who are less smart might not be able to make those choices, right? And that is one example here, where actually you have this super intelligent platform. So the context here was a bank that had lots of commercial off-the-shelf software systems. So they were not really that much into individual or bespoke software development. They wanted to use standard software mostly. they had to integrate it. So they had this highly proprietary integration solution, this super complex piece of software sitting right in the middle, connecting all of that stuff, right? And they wanted to replace that with an open source solution. The main reason here was that the vendor had phased out that product and, well, of course, had a new product that had the same name, but had nothing to do with the product that they were using, right? So they moving to the new version of that particular piece of software would have meant changing everything. So they decided, well, if we change everything anyway, we could just move to something that's open source. We keep hearing open source is a good thing. So they wanted to replace their magical integration broker in the middle. And that thing did tons of things, right? Like all this routing, conversion, transformation, lots of fancy IDEs where you could map things with XML from one part to the other. And it was super powerful, but it was a super big problem because nobody knew how to use it anymore. Nobody wanted to use it anymore. It was really, really hard to find something that could do the same things and to define a migration strategy. And what we did together was we replaced this thing by something far less complex. So in essence, we ended up with a pub/sub messaging thing in the middle. That was just a basic open source message broker that did a little bit of routing, transport area, but only very, very basic stuff. And we moved all of the other things into the endpoints, right? And we didn't use fancy graphical tooling to do that. We simply set up an environment that allowed for Docker containers to be deployed here that could do some of that stuff so that you could actually write it in a programming language. It was a surprise to some that there is actual software engineering best practices for doing that thing, right? I mean, like, version control and collaborative development and testing. I mean, those were all things that were not available in the magical broker platform. So they could simply use that. And we also had sort of a micro architecture blueprint sort of thing that said, well, this is the basic thing, right? This is a standard way to build one of those things. You can just use that to set up an application quickly, and then you can deploy that and use that particular thing. So the lesson learned here was that smart endpoints and dump pipes are much preferable to complex middleware. That's actually a fantastic talk by Jim Weber that you can look up. It's I think about 10 years old, but it's still awesome and matches every middleware in existence and addresses the same problem here. And again, be brave enough to pick a specific solution and avoid this overgeneralization, right? This generic thing in the middle did way too much. And it ended up having a ton of business logic, and you don't want business logic in your middleware. You want business logic in real programs that are either built by somebody else or built by you using a decent programming language. Configuration is possibly one of the major architectural design smells here. So let me wrap up the whole thing with a few takeaways. So the first takeaway is, don't be afraid of architecture, right? Architecture is something that you will have to address. Don't have to have a title to do that. It's just normal work. It's part of the decisions. It's sort of, if you compare it to Kevlin's talk before, which was awesome, he was talking about a lot of architectural aspects on the code level. This is true on the other levels as well, right? If you look at the overall system design, then designing which systems you build is also architectural work. Make a conscious decision of all of that. Choose the simplest thing that could work. It's that's a generic statement, but I think it's very true, right? If it feels complex, it might be good for your ego. It might be something that is a lot of fun. I like having fun at work. That's perfectly fine. But I don't like to suffer from bad decisions from the past. And I've found that choosing simpler things is almost always the better way to approach complexity. And allow for some evolution, right? Create evolvable structures. This whole microservice debate, whether you call it a microservice or a self-contained system or simply appropriate modularization, being able to change your mind on a more fine-grained level as opposed to this overall global level is always a good thing in your system's evolution, which you need to manage, right? Your architectural evolution needs to be managed. You need a little bit of governance. You need a little bit of thinking about those things. Don't just let them happen to you. And finally, if you happen to have that architecture role, then be very careful not to create roadblocks. Yeah, don't be the bottleneck. Try to create value and get out of the way. Provide solutions to the people working with you. Provide best practices and building blocks and maybe blueprints, stuff like that. If it's good, they'll use it. If it's bad, they won't, and that's a good thing. So that's all I have. Thank you very much for listening, and I definitely would like to look at a few of your questions. I saw you were quite active in the Slack.
Yeah, there are definitely several questions. I think you addressed some of them already, but what I've noticed, compared to the Kelvin's talk, it was actually questions. In your talk, people were just sharing similar experiences as you had. Okay. So they had the similar cases as you described, and people were just,
Oh dear Lord, that's a good reaction. Yeah. I like that.
Well, one of the questions that was asked by Muhammad is, what is the best design for ordered event management systems? And he mentioned Kafka as a keyword here. Would it be the best design?
So we're using Kafka in a lot of our projects, and it's good technology, so I don't have a problem with that. I do have a bit of a problem if Kafka becomes the central part of your long-term architecture. I don't like product names in long-term architecture decisions. I much prefer standards. So I'd much prefer to have my long-term integration strategy based on basic protocols, HTTP, maybe feeds for asynchronous communication. I don't object to using Kafka at all, but I prefer it to be an implementation detail within individual systems, right? But that's not, again, the risk with making statements like that is that I'm making an absolute statement, right? This is, and I just told you, you should not be making absolute decisions here. It always depends on context, and Kafka may well be a very, very good choice for your particular scenario. Again, just maybe a grain of salt. You should be aware that is a product decision and that you can become too reliant on that. You can, and I've seen projects run into a problem where Kafka is like the new ESB monster, right? It has you don't want that to happen to you as well.
Right. So yeah, actually some other when now people start adding questions.
Yeah. Oh yeah, I'll add a few links. I mentioned that before. Somebody said choosing the simplest thing that will work is unfortunately not so simple in my experience. And I think the point made here is that the example is that the developer says, just add this, it's simple and easy, and it might be totally wrong from a business architecture viewpoint. I think that is an excellent observation, and it actually shows that there is a tension between short-term and long-term goals, right? And again, absolute statements are risky, right? So if I say something like choose the simplest thing that could possibly work, it's a little bit like this Yagni thing that's also misused, right? You ain't gonna need it. It's the same spirit. The problem is that neither the statement choose the simplest thing nor the Yagni abbreviation are an excuse for switching off your mind and not think about it. But if you know something is happening, if you know the long-term effects will be bad, then don't do that. I mean, obviously, you're definitely allowed to think about more than the next 2 weeks. You're definitely allowed to think about what goal it is you want to move towards, and you also are allowed to think about long-term goals that are beyond your project goals, right? So immediate project goals might be in conflict with long-term things like maintenance or portability, whatever. You have to make a decision. Again, I'm just arguing you should make those decisions consciously. You should have a very good reason for doing them. You should not be doing something because you believe that it might one day possibly be, that's too weak. You should have a good case for that. We're adding that because the added complexity that we have here is worth it. We have a benefit that we get from it, and it's likely at least the likelihood is high enough that we will reap that benefit at one point in time. Because, for example, if you add configurability and never use it, it's just completely pointless complexity, reduction in performance. It's just bad. You shouldn't be doing that.
Yeah, actually, several people asked on Slack to share your last points. I guess you will share the slides. I will share the complete just in case, maybe put it also in Slack, so people have it. I mean, maybe last question from my side. But do you think that many problems that we have as developers or architects is because we are kind of disconnected from what the business is, from the business decision making?
Yes, I think that is a very common problem, and it's weirdly enough, it's a problem among the best architects and the best developers, because the best architects and developers very early in their life often become bored with what they perceive as boring business aspects, right? So they focus on all this technical complexity, and they love playing with. I'm myself like that. I love playing with technology, right? the problem is that this can lead you to spending way too much time with that and not considering the actual business complexity or the importance of the business thing. Of course, the reverse is true as well. You have people who are so focused on the business that they pick the crappiest solutions and then end up on a burning platform a few years later. So again, you have to make those trade-offs, but don't underestimate the need for understanding business complexity, even if you're a technical architect. I strongly advocate for considering the domain, learning the domain, understanding business stakeholders' needs, understanding how your organization makes money if it's in the money-making business, as most are. That is definitely a good choice.